Hi guys, we're going to start doing some videos on how to solve equations, and there are different levels to these problems. We're going to start out basic and we're just going to kind of build and build and build until we're solving some pretty complicated stuff. So in our book that we use in our classroom, this is chapter 3 section 3, but you might be learning from a completely different book if you're not in our classroom. So the topic is solving equations with addition, and I'm going to show you what this means. So to begin with, we're just going to try an example because it's probably easiest just to show you a problem. And for our example, we're going to figure out what x plus 5 equals 9 is. Now this is a very simple equation. In fact, it's one that I could probably figure out in my head and not need to show any work at all. Because all it means is x is a number. I don't know what it is, but some number plus 5 is supposed to equal 9. Something plus 5 equals 9. So like logically, I can kind of think in my head, what plus 5 equals 9? Oh, I know, 4. 4 plus 5 is 9. So I think the answer for x right here is 4. But I want to start getting ready for like higher level algebra where I'm going to have to work out my steps and show my work. So even though I can do this problem in my head, I want to show how I would solve it on paper. So here's one way to go about it, one strategy. I know that this is my equal sign and that x plus 5 is equal to 9. So wherever the equal sign is where I'm going to draw a line down the middle of my paper, dividing it in half. What I'm going to think about here is if something plus 5 equals 9, what I really want to know is what does just x equal? What is the answer for x? Which means if it's x plus 5 and I just want an x, I need to take this 5 and move it away. I need to get the 5 away from the x. So I'm going to take the 5 and be moving it over to this side of the equation. But to cross that line, one of the things I need to do is I need to do the opposite of whatever it is. So if it's x plus 5, on the other side, it'll be a minus 5. That moves it to the other side. One thing I can do is I can cross out the plus 5 because I've moved it. And now I've got what I want. I've got x all by itself. The 5 is gone. And now I'm going to do my math. 9 take away 5. Oh, okay. 9 take away 5 is 4. My answer is x equals 4, which is what we guessed at the very beginning, but now I've shown it on paper so somebody else can read my steps and kind of understand me. Let's try another one of these. Let's do an example 2. So I'll move this up a little bit. All right, example 2. Let's try a second problem. Let's say I have a mystery number, and I'm going to do this with it. I'm going to tell you I have 10 plus m equals 18. Now, m is a letter, but it's actually a variable. It stands for a number. It's a mystery number, and our goal is to figure out what is m. Well, I know 10 plus it equals 18. So I'm like 10 plus something is 18. I think m's 8. 10 plus 8. Isn't 10 plus 8 18? I think it's 8. But I need to show that another way. I need to show that on paper. So here's how I'm going to show it with algebra. If this is the equal sign, I'm going to go to where the equal sign is, and I'm going to draw a line down the middle of my paper, splitting this problem in half. On one side, I have the 10 plus m. On the other side, I have the 18. And what I really, really want is at the very bottom, I want to know what's m equal to. What's the answer? So here's the m. It's on the side. What needs to go away is this 10. I do not need this 10. In fact, I want to move it over here to the other side. So if you look at the problem, it's just a regular 10. It's not a negative number. It's a positive number. So I'm going to take that 10, move it all the way across my line. And when it goes all the way across the line, it changes from being a 10 to a negative 10 or a minus 10. That moves it to the other side. So I am going to cross the 10 off. It is now moved to the other side. M is now all by itself, which is great, and I'll just do my math. 18 take away 10. 18 take away 10 is 8. So m is equal to 8. I found the answer. Now, this is one way of showing your work, but there's actually lots of different ways you can do these problems. The big thing is pretty soon there's going to be lots and lots of steps that make it too hard to figure out these answers in our head. And these steps and this practice of organizing our work is going to make those big problems way easier than trying to figure it all out in our heads, basically. So let me show you one last thing. We're going to do an example 3. Okay. For example 3, what we're going to do is solve another one of these problems that looks pretty similar. We're going to solve for x, and we're going to take x plus 3, and we're going to say it's equal to negative 10. X plus 3 is equal to negative 10. Okay, this one might be a little harder to do in my head, but we've been practicing steps. We go to the equal sign, we put a line down the middle, and we split the problem in half. There's 2 sides now. And when I'm done at the bottom, what I really want is my answer to say x equals and then something. So trying to get x alone. So I see the 3. The 3 needs to get away from the x. We need the x all by itself. So I'm going to take that 3 and get rid of it by moving it to the other side. Now in the last 2 problems, I've been doing that by doing this, by drawing an arrow. And saying, hey, let's move the 3 over. It's a plus 3. It's going to cross this line. When it crosses the line, it becomes a negative 3 on the other side. And that's one way of showing my work. But the second way that a lot of people like to do is they like to say, think of it as like a teeter-totter, like on a playground. On a teeter-totter, if 2 people are sitting on it, it stays nice and balanced. But if one person gets off the teeter-totter, the other person drops really fast because they're heavy. So you have to keep a balance. Well, that's a way you can think about these problems, is that we're trying to balance out the left and the right side. There's 2 sides here. So if I want to take this plus 3 and take it away, 3 take away 3 makes 0. But I can't just do 3 take away 3 is 0 unless I do it over here too. If I take 3 from both sides, I'm balancing out what I'm doing. I'm taking 3 off both sides at the same time. The teeter-totter will not drop. It'll stay nice and balanced. That's okay to do. So some people think of it in their heads like that. They think of it as like a teeter-totter problem. And they're like, okay, take 3 away, both sides, take them both away. Negative 10, take away 3, means I have 10 negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 negatives. And then I have 3 negatives. 1, 2, 3. All together, I have 13 negatives. So x is equal to a negative 13. And that's my answer. Now it's kind of up to you how you want to show your work. If you look back at those 2 problems we did earlier together, if you want to just draw the arrow and flip the 5 and think plus 5 turns into a negative 5 and cross it out, you can do it that way. If you really like the teeter-totter way, then you're going to be writing minus 5 on both sides under it. And then you're like, oh, okay, well that gets rid of all of this because 5 take away 5 is 0. That's another way you can do it. So like looking at example 2 that we did together just a few minutes ago, you can draw the arrow or you can just write minus 10 under here. The 10s go away. It's kind of up, like I said, it's kind of up to you. But just remember, whatever you do to the left, you got to do to the right. Keep that teeter-totter balanced. And we are going to post a lot more videos about this and continue practicing. Thanks, guys.